Welcome to T3 Day 5 of Calculus. Today we're going to continue our work with areas under curves. Integrals. In this case, we'll be able to, in this example at least, exactly calculate them because we're dealing with a piecewise function for each segment here. Each segment is a straight line. So what is this one asking here? The area under the curve from -7 to -3. So in that case, we're looking from -7 all the way to -3. So we're looking for this area right here. So that's just a rectangle. What's the base of that rectangle? Well, that's going to be 4 times a height of 2, so it's 8. What about our next one right here from -3 to 0? So that's going to be this one right here. Yay, that one right there. And that's a triangle, so that's going to be 1/2 base times height. The base is 3, and the height is 2 in this case, so it's 6 times a half, which is 3. Now what about the next one? Well, that's from 0 to 3. 0 to 3 is this one, and keep in mind this is all below the x-axis, so it's going to be negative, and it's a triangle, so it's -1/2 base times height. So -1/2, what's the base? 3, and the height is 2, so in this case it's going to be -3. Now what about from 3 to 6? Well, that's back above the x-axis, and it's this triangle right here. So we again have 1/2 base times height, but it's positive because it's above the x-axis, so it's 1/2. The base is 3, in this case the height is 3, so it's going to be 9/2. Now what happens if it asks to go from -7 to 0? That's going to be this entire area. We did it in pieces, so you just add together the first two, so it's going to be 8 plus 3, 8 and 3 equals 11. Now what about the next one here? It asks from 0 to 6. That's going to be this entire area right there. So that's the next two. So that's going to be equal to these two numbers, -3 plus 9/2. So that's going to be -3 plus 9/2, which is -6/2 plus 9/2. So that's 3/2. Now what happens if you add them all together, all 4 pieces? Well, we did these two together already, so you just need to add those together. So it's going to be 11 plus 3/2 is equal to 22/2 plus 3/2, which is equal to 25/2. So in this case, we could find the exact areas underneath these, quote, curves, because they are straight lines and pretty easy to find the areas of because they're rectangles and triangles. So in H here says, write an integral expression that represents the total area f of x between f of x and the x-axis. Well, that's just going to be the integral from a to b, whatever the starting value is and the end value. And it's going to be the upper function, which is f of x, minus the lower function, which is going to be and the x-axis, which is just 0 dx. So in question 2, it gives this cubic right here, x cubed minus 9x squared plus 23x minus 15, and it says sketch the graph of f of x and find the x-intercepts. So this is a cubic, you might be able to factor it, but since you can use a calculator, it says explicitly use the calculator. So if you use a calculator on this one, it looks like this when you graph it, and you'll notice that it looks like it crosses in 3 nice places. It actually does cross. If you use the second calc function and do left bound and right bound and guess, you will find that the 3 values here, so I go back, it's going to be 1, 2, and 4. So the x-intercepts are 1, 2, and 4. Just look at that one more time. 1, 2, and 4. So if we sketch the graph, it kind of looks like this right here. So it comes in at x equals 1, x equals 2, and x equals 4. It's important for the next section of questions here. So now we need to evaluate this with n equals 100. That's 100 subdivisions, and when n is that big, you do not do this by hand, and it's 0 to 5. Now we're going to use the Riemann Sum Decimus Calculator. This is a really nice one because it graphs any function, and you just need to make sure you play with the sliders. So here's the function in this Riemann Sum Calculator. I put it in up there. Goes from 0 to 5. Let's change the number of inputs right here to 100. So if we change this to 100 here, it gets all fuzzy in there because if you zoom in, you'll see all of these. See all the rectangles right there. So what did we do here? We did this function right here, starting at 0 and going to 5 with 100 intervals. Which one are you going to do here? Set c equal left. So left is c equals 0. So when we did it with left, it's -6.628. Let's just change it and see what happens. 1 for right-hand sum, -5.878. You get the left hand and the right. So in the next section, the question asks you to find the total area. So when we run this integral just from 0 to 5, if we run it from 0 to 5, you take the red area is negative and the green area is positive. But with total area, we need to make sure we only make it positive. We only make it positive. There's no negative area when you do total area. When you do total area. So what you do is you still go for this one from 0 to 5, but if you want the total area, what you're going to do is you're going to have the absolute value of f of x minus 0 dx, the absolute value. What that does to the function is it flips anything that's below the x-axis above. So total area means only positive. So if we go back here, we need to change this a little bit. That would be the net area, meaning positive and negative added together. But if you want the total area, all you do is you change that original one from a to b of the absolute value of f of x minus 0 dx. Now it's 0 because it's the x-axis. It could be a different place. We can use a different function there sometimes, but if it's the x-axis, it's just x equals y equals. So all I did here was I put abs in front. Abs means absolute value, and look what it did. It took this section and just flipped it above, reflected it over the x-axis, and now the total area, we could do it with a left and right estimates right there, left hand and right hand. So you get 14.6, change it, and then you get 13.873. You can average those two. So it's only positive when you're doing total area. Net area, you would take out this absolute value. If you want the total area, you just do the left and right using our Decimus Riemann calculator and then average them to end up with 14.2